How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at concentrations and conversions. Specifically, we want to be able to express and convert between various units of concentrations, including mass percent, parts per million, parts per billion, mole fraction, molarity, and molality. So let's get to it. So the example I'm going to keep coming back to is this scenario. We have 36 grams of HCl and we dissolve it into 64 grams of H2O. How many different ways can we describe this concentration? Well, we can use mass percent, specifically like percentage of the mixture. How much, what is the percentage of HCl in the mixture? And we're using mass in this scenario. Parts per million, parts per billion, molality, mole fraction, molarity, and how can we convert between these two? You see the units and the symbols used to abbreviate them. So that's what we're going to take a look at. Let's take a look at mass percent. So we know percent is the mass of the solute divided by the mass of solution times 100. Now remember, the solute gets dissolved and the solution is the mixture. So we want the mass of the thing being dissolved and divided by the mass of the combination, the total mass, right? So if I'm taking a look at this example, 36 grams of HCl is dissolved into 64 grams of H2O. What is the percent of HCl? Well, again, the mass of the solute will be this 36 grams. So 36 grams divided by the mass of the solution. Well, the solution is the HCl and the H2O. So the total mass on the bottom will be 36 and the 64, which gives me 100. And that's part of the reason why I chose these numbers. So when I do 36 divided by 100 times 100, I end up with 36%. So that'd be 36% of HCl by mass. So parts per million looks pretty similar to the percent by mass formula. So parts per million is equal to mass of the solute divided by the mass of solution. That's still the same, but times by a million. So again, same setup, but what is the parts per million for this? Again, mass of the solute, which is my 36 grams, divided by the mass of the solution, so 36 plus 64, divided by 100 grams, times by, in this case, a million, or 10 to the 6. And we end up with a much bigger number because it's out of a million instead of out of 100. You end up with like 360,000 parts per million. Now this, probably not the scenario where you want to use parts per million, right? Percentage is probably a more appropriate unit of measure in this scenario. Parts per million, you're going to use more when you're using minute concentrations. Maybe when you're worried about like the levels of lead or some other contaminant in water. You're worried about parts per million because even that tiny amount can have an effect. So probably not a great unit for this scenario. Parts per billion is the same kind of thing, except instead of out of 100 or out of a million, it's out of 1 billion. So the setup is still essentially the same, mass of solute divided by mass of solution, but this time it's times by a billion. So same combination, same mixture here, 36 grams of HCl dissolved into 64 grams of water. What is the parts per billion? Again, the mass of the solute, which would be that 36 grams, divided by the total mass, which is 100 grams, because it's the 36 plus the 64, then times by a billion, or 10 to the 9th. And I end up with an even bigger number. Now let's see if I can do all the zeros right. Right, so I'd end up with 360 million parts per billion parts. So again, probably more appropriate to use percentage in this kind of a mixture, but parts per billion, an important unit used when you're measuring things like contaminants in water. So molality is moles of the solute divided by kilograms of the solvent. So we use this often when we're looking at colligative properties, where like a freezing point depression or boiling point elevation or osmotic pressure, molality is going to be the more useful unit of measure. But let's say we have this same scenario. How can we describe its molality? We have 36 grams of HCl dissolved into 64 grams of water. What is the molality? Well, first I need moles. So I know that moles is equal to grams divided by the GFM, the gram formula mass of HCl. So I would go, all right, well, I got 36 grams of HCl, and if I only go to the ones place, the gram formula mass for HCl is 36 grams per mole, so I end up with 1 mole. Now, kilograms of solvent, well, if I have 64 grams, all right, so how do I get kilograms? It's going to equal the grams divided by 1,000, which is because I do 64 grams times by, well, there's 1,000 grams in 1 kilogram. So 64 divided by 1,000, I end up with 0.064 kilograms. So now I can plug it into my equation. My molality is going to equal 1 mole divided by 0.064 kilograms of solvent. Now notice it said solvent, so I was just talking about the H2O, not the combination of the two. And when I do that, I get 15.625 molal. Or I could say moles per kilogram of solvent. Right? So there you go. So now mole fraction represented by X is how many moles of the one thing divided by the total moles in the mixture. So if I'm, again, talking about this mixture, 36 grams of HCl dissolved into 64 grams of H2O, first I need to know, well, how many moles of HCl do I have? And then the second part, total. Well, I need to know how many moles of H2O do I have as well. So moles of HCl is going to equal the grams divided by the GFM. So I end up with 36 grams divided by 36 grams per mole, and I end up with 1 mole of HCl. Now I have to do the same thing, but for water. You know, how many moles of water is 64 grams? Well, I have 64 grams of H2O divided by, I need to figure out the gram formula mass for H2O, which is roughly 18 grams per mole. So when I do that math, I'm going to have to go to my cheat sheet because I'm not that good at math. I end up with 3.56 of H2O. So if it wants to know what is the mole fraction of HCl, well, how many moles of HCl do we have? We have 1 mole of HCl divided by the total moles, which I have still that 1 mole of HCl, but also 3.56 moles of H2O. So I really end up with 1 mole divided by 4.56 moles, and that equals 0.219, and that is my final answer. This one has no units because look what happens. You got moles divided by moles. Moles cancel out. You have no units. So molarity. For molarity, we know it's moles of solute per liters of solution. So now the key here is that volume is the mixture of the two. What is the volume of the mixture? And that's important because if we look at this scenario, 36 grams of HCl is dissolved into 64 grams of H2O. What is the molarity of HCl? And then they give us the density. And the reason for that is we need to know what is the final volume of this mixture. We know, like for water, it has a density of 1 gram per milliliter, so 64 grams of water is 64 milliliters. But when we dissolve HCl into it, that's going to change its volume, and therefore it's going to change its density. So we need to know the volume of the mixture. This unit is more useful when we're doing like solution chemistry, where we need to know how many moles of a reactant are in a certain volume of our solution. So it's used super commonly. So how do we do this? Well, first we need to know moles of solute. So again, same process. It's going to be grams over the GFM. And for HCl, it's 36 grams that we use divided by 36 grams per mole. And we get roughly 1 mole of HCl. But now we need to know the liters of our solution. So they give us the density of our solution. So we need to know the mass of our solution so that we can find the volume. So let me do that math. I know density equals mass over volume. If I'm solving for volume, I got to rearrange. I get volume equals mass over density. So the total mass is going to be for our solution, 36 grams plus the 64 grams. So my total mass is going to be 100 grams divided by this 1.49 grams per milliliter. And when I do that math, well, let's see, I get 67.1 milliliters. Now you can see the volume for that is greater than that of just the water, because when we add more stuff to the water, we change the volume, we increase the volume. So if it's got to be in liters, again, I got to now convert that. 67.1 milliliters times, well, 1 liter is 1,000 milliliters. So when I do that math, I end up with 0.0671 liters. So now I can just finally plug in. I get 1 mole of HCl divided by 0.0671 liters, and I end up with 15.625 molar? I don't think that's right. That's not right. I'm sorry, I'm looking at the wrong thing. So when I do that math, I end up with 14.9 molar. So that would be my final answer for molarity. Can I go forward? All right. All right. So conversions, mass containing units. Let's look at some of the easier conversion things first. So if I have percent, it's pretty easily converted to parts per million, pretty easily converted to parts per billion, right? All three of those start with mass of solute divided by mass of solution times some number. If it's percent, it's for every 100, right? That's percent. Right, miles per hour is how many miles for every hour. Percent, cent meaning like 100, it's like century. It's for every 100. Parts per million, a million. Parts per billion, a billion. And then molality, if I have the mass of solute, I can pretty easily get the moles of my solute. And chances are I also know the mass of my solvent. So if I take a look, a solution of HCl and water is 36% HCl by mass. What we're going to do is we're going to assume that we have 100 grams of that. So what is the parts per million? Well, let's see. I know I have 36 grams of HCl if I'm assuming 100 grams divided by the mass of the solution. Well, I just assumed 100 grams, so 100 grams, 36 divided by 100 times by, well, if I need a million now, I times it by a million, parts per million, and that's how I end up with that 360,000 parts per million. Parts per billion, same process. Assume you have 100 grams. That tells you have 36 grams of HCl out of 100 total, and then times that by a billion this time. So you get parts per billion. You end up with 360 million parts per billion parts. Now, molality is going to be a little different, right? So molality is moles of solute per kilogram of solvent. Well, I know if I have 36 grams, I divide it by the GFM, which in this case is 36 grams per mole. I end up with 1 mole. So I've got my moles of solute. Now my kilograms of solvent, well, if I assumed 100 grams and 36 of it was HCl, I know I have 64 grams of my solvent. So now I just got to convert that to kilograms. So divide by 1,000, I end up with 0.064 kilograms. So now my molality, I just got 1 mole divided by 0.064, and then that's, I think that was the 15.625 molal. Right, so not too bad. It does get a little more complicated when we want something like mole fraction. So it's the same process though. If we have a percent, the easiest thing to do is assume that we have 100 grams. So if I had 100 grams, that tells me that 36 grams of it was HCl, and then the rest of it is going to be H2O. So how many grams of H2O do I have? 64. And if I need the mole fraction, I remember it's moles of the thing divided by the total moles. So I got to go, all right, well, 36 grams of HCl divided by 36 grams per mole, I end up with 1 mole of HCl. Now if I have 64 grams of H2O, divide that by the GFM of 18 grams per mole. And let's see what I get when I do that, because I forget. 3.56. So now to get my mole fraction, I just do, all right, well, I got 1 mole of HCl divided by total moles, 4.56. And that's when I get the same answer as when I solved it originally. I got a 0.219. That's my mole fraction. Now, if I want to go in the other direction, they were like, hey, we have a solution where the mole fraction is 0.219 for HCl. What is the percent mass for HCl? Well, again, assume 1 mole total in this. So you, all right, well, I have 0.219 moles of HCl divided by 1 mole total. Well, I can do the math and go, all right, well, if 1 is 0.219 moles of HCl plus some number moles of H2O, let me just do the math. I get moles of H2O equals 0.7. Oh, that's not a 7. That's the next number, 0.781. Right? So now I go, all right, well, let me convert that to grams, times it by the GFM, 18 grams per mole. I end up with 14.058 grams. Now I do the same thing for HCl. I have 0.219 moles of HCl, times it by 36 grams per mole, and I end up with 7.884 grams. So to get the percent, it's going to be the mass of the HCl, 7.884 grams, divided by the total mass, so 7.884, and the 14.058 times by 100, and once you know it, I end up with 36% as my final answer. So that's how you convert between percent and mole fraction. So percent and molality. How are we going to do that? All right, so for percent and molality, same idea, assume 100 grams, right? So we know that molality is moles of solute divided by kilograms of solvent. So if I said I had 100 grams, it tells me that I have 36 grams of HCl. I need moles, so convert that by dividing by the GFM, 36 grams per mole. I get 1 mole of HCl. So now, again, if I had 100 grams, and I subtracted the 36 grams of HCl, I get my 64 grams of water. So now I need it in kilograms for molality, so I divide by 1,000, and I end up with 0.064 kilograms of H2O. So now I can just plug and chug. 1 mole divided by 0.064 kilograms gives me the molality of 15.625 molal. It's not too bad. A solution of HCl has a molality of 15.6. What is the percent mass for HCl? It's the same thing, but in reverse. So we have 15.6 molal. So that's the same thing as saying 15.6 moles per 1 kilogram of H2O. So if I need its percent by mass, well, now I need to convert this 15.6 moles into grams. So I times that by 36 grams per mole, and I end up with 561.6 grams of HCl. Now, this kilogram is just H2O. It's just the solvent. So if I want the percent by mass, I got to take the mass of my solute 561.6 grams divided by the total mass. So I have 1,000 grams of water and 561 grams of HCl. So I end up with 1561.6 grams of my solution times by 100. And then, wouldn't you know it, I end up with 36%. All right. And then probably the worst conversion is molarity and molality. Because molarity is moles of solute per liters of solution, but molality is moles of solute per kilogram of solvent. So solution and solvent aren't the same thing. The solution is the mixture. The solvent is just the thing doing the dissolving. So we're going to need more information. We're going to need the density to connect liters of the solution to the mass of the solvent. So let's say we had a solution of HCl as a molality of 15.6. What is the molarity of HCl? So let's start with what we know. They told me the molality is 15.6. So that's 15.6 moles per 1 kilogram of H2O is my solvent. They want the molarity. So let's assume we have just this, 15.6 moles of HCl and 1 kilogram of H2O. What would the total mass for that be? Well, I know I have 1,000 grams or 1 kilogram from just the water. Let me figure out how many grams HCl I would have. So I times that by the GFM of 36 grams per mole, and I end up with that 561.6 grams of HCl. So if I had 561.6 grams of HCl in 1 kilogram of H2O, so let me add 1,000 grams to that for H2O, the total mass of my solution is 1561.6 grams. Now they told me my density. So I go, all right, well, if I know my grams, I can figure out my volume, right? Because density equals mass divided by volume. So if I wanted my volume, it's the mass divided by the density. So my mass is this 1561.6 grams divided by 1.49 grams per milliliter, and I end up with, 1048 milliliters, or 1.048 liters. So now I can go back to my molarity and go, all right, well, I assumed I had 15.6 moles of HCl, and I just found out that my volume would be 1.048 liters. So I plug and chug, and I get 14.9 molar as my final answer. So, converting. Break the unit down. What are they telling you? What do you know? Where do you need to get? And just figure out how to get from A to B. That's it. Hope you found it helpful. Can you summarize expressing and converting between various units like mass, percent, parts per million, mole fraction, molarity, molality? I hope so. Okay, bye.